Welcome to a new episode on the Technomora channel. We really hope you will enjoy watching it and invite you to tell us what you think of it by leaving your reactions below the video. And now, please allow me to present your host, Technomora.
I don't know why this video is turning out to be a video about potential planned obsolescence devices, but that's just how it turned out. Yeah, and the next, let's say, potential patient on the slab is this inspection light, something, let's say, DIYers or mechanics would use to inspect, say, the underside of a car, or some darker spots in an attic or a garage or something like that. Now, there is a kind of a special collection bin at the DIY center where people can drop off used batteries and or used lamps. And I saw this inspection light sticking out of one of those collection bins, and it was simply too irresistible to me not to take it away with me. Usually I don't nose around in dirt bins or in somebody else's dirt, but this was just, like I say, too irresistible to leave it behind. I reasoned, if I can't repair this, there are at least a few parts inside of it that I could reuse, and if not, this has 60 LEDs, so possibly, say, if 1/10 of the LEDs are bad, I would still have over 50 LEDs free for nothing. Yeah, all I would need to do is to desolder them, and that's it. Now, before I do that, before I dissect this unfortunate inspection light, I want to see what's wrong with it and potentially find a way to make it work and to make it last longer than what it is probably advertised for. So, yeah, well, here we go. After closer inspection of this inspection light, I could not find any obvious screws or nuts or locking mechanisms which keep it together. Yeah. What I did notice, however, is that the grip of the lantern or lamp, if you wish, is made out of a sort of an industrial rubber. Yeah? And it's my guess that at the factory they heat up this rubber so that it becomes malleable, and then they slide it over the electronics, which themselves are encased in some sort of a hard plastic casing. And you can see part of the electronics down there. Yeah, you can at least see a couple of resistors or stuff like that. So, and this edge is hard plastic, not the same rubbery stuff like the grip. So it's my guess that if I give it a few short blasts of my heat gun, that I can make the rubber malleable again, or at least enough so that I can strip it off the base of the inspection light. Alright, now obviously a heat gun shoots out air at about 350 degrees C, which would be, I don't know, somewhere around 500 degrees Fahrenheit. Okay, so obviously you shouldn't use this around inflammable material like I'm doing in the lab. You should actually do this outside if you can, but since it's night and it's very cold and wet outside, I will, due to circumstances, do it inside my lab. Anyway, so I'm going to use a broad flat screwdriver to wedge between the hard plastic and the rubber, so that to help me to strip it off if possible. Mind you, I've never done this before, so it might not work the first time around. So, but what do we have to lose, right? Nothing. So let's give it a shot. Rubber is red hot, so to speak. Let's see if we can release it. Oh yeah, here we go. Ooh, it's hot. It's really, really hot. So the top of the case is released, so that's a good thing. Now what? Okay. Yeah, it's not too solidly anchored, but okay, so I will need a minute to have a look at this. I need both my hands to do this, and it's relatively dangerous, so give me a moment and I'll heat it up again and then see if I can heat it all over and then strip it off. Well, heating the top all around the circumference did make it release from the top of the inspection light, and I can kind of look inside of it, but I don't know if you can. Let's give it a try. So there I see something which looks like a battery at the bottom. Alright, and then of course the PCB with all the LEDs soldered to it, and a couple of resistors at the top. So we're a bit further, but now I need to find out how to release the whole device, as it were, from the bottom of the case. I discovered that the whole PCB, in fact, should be able to slide out of the case. Yeah, and you can see it move when I pull on it. Alright? Now, the problem is the lip of this black ring is holding it back. So what I'm going to do is I'm going to make two tiny cuts with a grinder wheel, with a mini grinder wheel, okay, and then see if I can slide out the whole thing. Alright, noise alert. If you don't like the noise of grinding plastic, then turn your volume down now. there you go. Now let's see. No, not enough, I would say. I still need to grind off a little more. Yeah, a little more. Alright, there we go. Okay. Oh, now the LEDs are blocked against the lip. So I will need to make a few more cuts to release the strip of LEDs. Prolonged heating with the heat gun did not have the expected result. For understandable reasons, of course. I mean, the ones who designed this wanted to make sure that nobody could ever remove this for any sort of reason. I would say out of security considerations, but also probably out of commercial reasons. Yeah, nobody wants to see somebody rip off their invention, right? So anyway, I think in the end what I will have to do is cut this open, and I will make with my Dremel tool a cut all along the length of this, yeah, all the way up to the charge plug here. You should be careful not to Dremel into the battery, of course, because that might cause some trouble. Okay, it would seem the strategy worked. I'm just as curious as you are what's inside of here. But I'm afraid I'll have to make a second cut, because this is now very, very tough to break open, unless of course I use heat. Well, there you go. I literally had to destroy the grip of the inspection light to get its innards out, and there you have it. So it's a bunch of batteries, I would guess rechargeable batteries, which are shrink wrapped, yeah? A connector and a little switch, which is connected to the main board. So what I next need to do is to extract the board with all the LEDs from this translucent tube. Now you can tell the heat deformed the tube quite appreciatively. So yeah, the tube is completely deformed. So what I'll do next is I'll heat up the tube, and when the plastic is mellow enough, I think I can pull out the PCB from the tube. I'm measuring the battery, okay, and I'm measuring it by placing the plus of the multimeter here on this red wire here, and then the negative, which seems, so the black wire of the battery, so this wire here, seems to be connected to the switch, and then via a little red wire seems to be connected to the charging plug. So let's measure, and I seem to be measuring 13.1 millivolts. Okay, so yeah, the battery is basically dead. Yeah, the battery is dead. So does this mean that all the batteries in the battery pack are dead, or just one battery? I don't know. So but I want to disconnect the battery pack from the rest of the device, and then connect up the LEDs to my power supply over there, and then see if I can get it to work. That will at least tell us whether the board is still functioning and how many of the LEDs are still functioning. And then we can investigate a bit closer what else might have failed in this device. Alright, so let's measure a few resistors. Okay, so the large 5 watt resistor you see here is coded red, black, black. So that would mean 20 ohms. Okay, so let's see. .3 ohms. 20.2. Okay, close enough. So the little one, the quarter watt resistor you see here, is coded orange, black, red, orange, black, red, let me see, no, orange, black, or brown. So that would be 300. Okay, so 300 ohms. Let's see. .356.3 ohms. Not so very good, but okay, let's say in the ballpark, more or less. And then we have these two 1 watt resistors here, and these are color coded brown, green, black. So that would be 1, 5, nothing. So 15 ohms. Let's see the first one, the top one. .3 ohms. So let's see the bottom one. On the dot 15 ohms. Alright, so the resistors check out, let's say, reasonable. Certainly the big ones, the smaller one down here is off value by quite a bit, but let's say within limits, still tolerable. And then there is the diode. Okay, so the diode, if measured in counter polarity, should be like an open lead. Yeah, so it should measure open. And if connected anode to positive, cathode to negative, it should show a value. Alright, so let's measure. So the anode of the diode is connected to this contact here, and the cathode is connected to this. .83 megohms. Okay, now we reverse the polarity. Open lead. Okay, so you could say the diode is functioning correctly. Alright, so these components are okay. I didn't measure out the switch yet, nor the charge plug, but what I'm going to do next is disconnect the PCB with the LEDs and then connect it up to my power supply and see if we can get it to work on its own. Okay, I figured out how the LEDs are connected. So, first of all, there are two banks of pairs of LEDs, and each pair is connected anode to cathode. Okay, so anode to cathode, etc. all the way down the board. And you have the same thing here, so anode to cathode, and then all the way down. Then these two banks are connected in series, so one bank will be powered by, roughly speaking, 3.5 volts. The other bank will also be connected roughly by 3.5, fed by 3.5 volts. And then, of course, since the battery pack would deliver how much? 7.2 volts. Alright. So then the power of the battery pack would go through one bank of LEDs and then through the other one in series. I hooked it up to my power supply, and right now I'm sending 3.2 volts through the whole bank of LEDs, but not much is happening. So let's push up the voltage a little bit. So 3.8, 4, 4.3, 4.6, 4.9. There you go. I think you can start to see the LEDs glow, right? So let's push it up to 6 volts. Alright, so this is 6 volts. Not very bright, and the whole board is consuming right now around 40 milliamps. And show you what that lonely LED at the bottom of the PCB looks like when powered. It's just a simple red LED, and in my opinion this was just an indicator showing you whether there was indeed power on the connector. So in other words, one could assume the batteries would be recharging when one saw this little single red LED lighting up. So yeah, it's just an indicator for the power. Alright, so we determined that apparently the LED board seems to be functioning great. We also determined that the battery pack is dead, so no charge, or practically none, on the battery pack. So the only two things I still need to measure are the connector and the switch, and see whether those failed. Alright, I hooked up the switch via a few test leads to my multimeter, and when I press the switch, nothing really happens. So most probably the part that failed in the inspection light was the switch. Although, in all fairness, I should say that the switch was slightly damaged by the heat I applied to the inspection light to disassemble it. Alright, so I connected a plug, a charging plug, alright, to the little connector, and via crocodile leads to my multimeter. So now let me show you what happens if I shorten the leads to the connection plug, to the charger plug. It should show a short on the multimeter if it still functions. Let's see. And it does. Well, a few ohms, but that's due to contact resistance and such. But 2.2 ohms, that's well within limits. So I would say yes, the charger plug does function. Alright, I connected the battery pack up to my power supply, and right now I'm sending 8 volts, 70 milliamps through the battery pack. Alright, we'll see. So it's now 4:30. So we'll come back at 5, and normally the current should start to drop. Alright, so it should start to slowly drop to, say, roughly 20 milliamps or so. And already it's dropping. So it might be that the battery pack is charging still. So let's see. Half an hour from now we'll have a look. Alright, so I hooked up the battery, but after roughly 10 minutes I immediately saw it would be a futile exercise trying to recharge it. So if we measure the power it gives off now, let me show you. Yeah, so it's 6.5 volts, let's say. But you know, the multimeter is drawing a tiny amount of current from the battery. Alright, and by tiny amount I mean like microamps. Alright, and already you can see the power of the battery dropping. So we're at 6.4 volts now, yeah, and it's steadily dropping. So I would say this battery pack here is dead, is toast, and needs to be disposed of in an ecologically friendly way, which is that next time I go to the city dump, there's a special used battery container there, and that's exactly where these will end up. Alright, so don't throw them just in your regular garbage. Take them to the city dump and dump them in the appropriate container. Alright, so what is our conclusion for this inspection light that we dissected? Yeah? And we can properly talk about a dissection. We cut it open completely. Yeah, we didn't leave one single part whole. Well, the conclusion is that first of all, the construction of this particular inspection light is or was cheap. Yeah, so it consisted only of a nickel metal hydride battery pack, rated at, by the way, 800 milliampere hours, 7.2 volts, no name. Alright, a cheap little switch rated at 250 volts AC and 6 amps current. So a single pole, single throw switch, and a simple charger connector, plastic housing. I don't see any rating on it, but one could assume this is rated for low DC voltage and amperage. This in fact seems to be working just fine. Alright, and what also works just fine is the PCB with the LEDs, including the components, the passive components which are on it, like the resistors and the diode. The PCB itself looks reasonably nice and clean. So with the PCB itself and the LEDs, I find nothing to fault. Alright, so what I would say, the probable source of failure, which would seem to point to planned obsolescence, is of course the most heavily used part on the inspection light, which is the switch. Possibly the battery pack itself also failed, but I'm not going to cut open the batteries to have a look whether that's the case, but trust me, it's not holding a charge, or barely. So yeah, the 2 points of failure are the most obvious ones, I would say, which is the switch and the battery pack. So my conclusion is, can we improve on this? We could, I suppose, if we found a way to, let's say, gently disassemble the inspection light. We possibly could improve on it by using a lithium battery and a small charger, let's say print board, which regulates the current going through the battery, and possibly a better quality switch. Of course, I have to say that I don't know how much this specific inspection light was sold for. No clue, but I'm guessing it must be somewhere around, I'd say $10 or $15 maybe. So what could you possibly expect for $10 or $15, right? So in the end, I end up with, like I said at the beginning, with a bunch of very nice white LEDs. I have 60 of them, 60 white LEDs and one red one, and a few power resistors. So, and a nice little PCB. So yeah, I might still find some use for the strip, the LED strip, but probably what I'll end up doing is unsoldering the LEDs on some Blue Monday where I don't feel like doing too much, it's good occupational therapy, and I don't have to spend money on new LEDs. Perfect. So the conclusion is no, you can't improve on this, at least not as far as I can tell, by a simple mechanical operation. That's impossible. These things are designed in such a way that when you open them up, they are effectively destroyed and unsafe to use. So the best thing you could do is reuse the LEDs, reuse, if you're lucky, the battery pack, and possibly reuse the charging connector, and that's it. I'm going to attempt the repair of a mulcher which a friend brought to me, and apparently, according to my friend, the mulcher refuses to start, so it just doesn't want to switch on anymore. And so yeah, he asked me if I could take a look at it and maybe perhaps repair it. Now, I have to admit, I don't use mulchers. In fact, I can't even remember if I ever used one in my life, but it seemed to me like an interesting challenge to get this one to run again. So yeah, let's have a closer look at this mulcher, which is a, let's see, a Sabo Comstar Mulcher, and here is the serial number and the specifications. It's obviously a 220 volts 50 hertz machine. According to what my friend told me, the mulcher has basically an on-off switch, which is this switch here, a directional switch, which makes the mulcher motor turn either in one direction or in the other, and an emergency stop button. And these three buttons are underneath this yellow cover here. So to open up this cover, you need to pull a tab from each corner, a tab like this, with the help of, let's say, a little screwdriver or something like that. Now, I took my time to make a little diagram on a piece of cardboard of how the electrical connections are underneath, okay, and because unfortunately, I think, I will have to disconnect the switches to have a look whether these switches are still functioning or not, and maybe even give them a clean up. And also, I'm not sure yet, but it's my guess that the motor, which is right here, can only be accessed from the top. And to be able to access the motor and the electricity connector here, I will have to unmount this, let's say, black top. Alright, I disconnected the button assembly from its box, and the next step is to measure whether the AC input of the mulcher still works. So the AC input is right there, alright, and I connected up my multimeter to, let's see, yellow, the left pin. Okay, so now I'm going to connect my multimeter, which shows open lead, okay, to, okay, right now it's connected to the brown lead coming from there, and that gives me an open lead measurement. So brown apparently is not connected to the AC in. So now let's try the black wire. Okay, open lead. Okay, so now let's try the blue wire. Okay, there we go. That gives us 1.5 ohms, 1.4, which would account for the resistances of the measurement wires and contact resistance and all that. Anyway, so the blue wire, which comes out of there, is actually connected to the left pin, the left AC pin. I'm saying left because, well, it's a non-polarized AC in, okay, so it could either be the neutral or the phase wire, okay, so it doesn't really matter for now. So let's measure the black lead, which goes to the other pin. Alright, so remember the yellow went to the blue lead. Okay, hang on, I'm doing this one-handedly. Alright, so now we're connected to the right AC in pin. So we're on the blue lead. That gives us open lead. Now let's connect to the black lead. Alright, and that gives us 2.5 ohms, a slightly higher resistance. Let's measure the brown wire again. There you go. Okay, this is a brown wire. Open lead. Okay, so the two AC input pins go to respectively the blue and the black wire. Alright, so it turns out that this switch, the blue switch, which according to my friend was the directional switch, so which makes the motor of the mulcher run either clockwise or counterclockwise, is a single throw double pole switch. Alright, so the common is the center pin. The A or B position are the two outer pins, and it's double poled, so you do for each pole you have the same type of switching, so from the center pin to either pin A or B, and they are crossed, so which would indicate indeed that the polarities are crossed going towards the motor. Now I checked the pins out, I measured them with my multimeter, and they check out. I'll show you in a minute. And then you have the main switch, which is this rotary switch here, which turns the whole machine on or off. And that switch, at first glance, doesn't seem to work. Now, I did notice one thing, which is that burn spot right there, okay? So there's a burn mark there. And that seems kind of suspicious to me. So, I'm still not sure what the solenoid's function is, although I have the impression that this is only there to keep the machine in on position once it's running. But by pushing in the emergency button, you would release the switch. But I still need to have a closer look at the internal mechanism. And for that, I need to disassemble the whole button assembly. And it seems that the buttons are kept in place with Torx screws. So the first thing I need to do, obviously, is to remove the black and the blue button, so the main switch button and the directional switch button. Alright, with the help of a Torx screwdriver, I released these 3 little Torx screws, and then I managed to remove the button assembly from the base plate. It turns out that the single throw, actually it's a double throw, double pole switch is no, actually it's okay. It's not even it's a temporary push button. Okay, so it's a single throw double pole switch with permanent push action. Okay, like this. And yeah, so the buttons just came off just like that. Okay, so the main button assembly, in fact, is clamped between this little holder here and that little holder there. So you just need to pull gently on these yellow tabs and the whole switch, main switch assembly released. The main switch seems to be a push button on off. Okay, so yeah. Now I need to have a closer look at those damaged contacts, or at least I think they are damaged. Where are they? Oh, there they are. So I need to have a closer look at those burn marks right there. Alright, I disassembled the main switch from the solenoid assembly by lightly pulling on these tabs you see here. So pulling away these tabs gently releases the main switch from the solenoid assembly. Now the main switch works like this. Let me show you. So you have the actuator, which is this part here, which pushes down on a lever assembly. In fact, by rotating the main switch button there, you push down this lever, which in turn pushes on this lever here, which in turn actuates 2 contacts here. By pushing on the main button, you actuate the contacts down there. So if you push hard enough, there, you see, you actuate those 2 contacts there. When you release the button, so in the off position, you release these two contacts again, so thereby switching off the motor. Now have a closer look at the contacts. That looks pretty ugly. I would say whenever the motor was switched on or off, there were quite a few sparks in here, and after a while, due to heat and all that, the contacts were blackened so much so that they probably just stopped functioning altogether. So what I'm going to try is clean up these contacts and then try to find a solution to avoid having so much sparking in here. Alright, I took my contact cleaner and I'm going to try to clean up the contacts a little. And see whether we can salvage the switch and then maybe find a way to reduce the sparking. Alright, I'm going to build my own little spark suppressing circuit, which consists in fact of a 47 nanofarad 630 volts rated polypropylene capacitor in series with a 1 watt 1 megohm resistor. I would say the parts are perhaps a little bit over dimensioned. I mean, I could use a smaller capacitor probably and a slightly smaller resistor, meaning maybe only half a watt resistor instead of a 1 watt. But you know, when I build this back in to the mulcher, I want to be sure that the parts never fail. So, you know, safety first. I just took these parts. So what I'm going to do now is solder the two parts together and then mount them, each of them, across one contact, you know, and that way the sparks should be safely suppressed, and this type of problem should never reoccur again. Alright, the spark suppressing circuits are installed. Okay, I think it's called sometimes a snubber circuit. I don't remember correctly, but I think it's also called a snubber circuit. Either way, the function of these little circuits that I built is to do exactly what we hope to do, which is to suppress sparking inside the switch's body. Okay, which of course which burnt the contacts, and which in turn of course then did not make sufficient contact anymore to switch the engine on or off. At least that's what I think. We still don't know if the engine, or the motor I should say, of the mulcher works still, but in my opinion, having cleaned up these contacts and now installed the spark suppressors, I think the machine should work properly now. Alright, the button action rod, or the push button actioner or lever is reinstalled, and by the way, it needs a little spring at the bottom. But this whole assembly is really touchy. If you don't want to have springs flying off in all directions, better be careful when mounting it back, okay? So at the back of it are the snubber circuits, or the spark suppressing circuits. Alright, so we're going to mount the whole thing together again, and then we're going to connect it up to the AC without connecting it to the motor, and then we're going to have a look whether it still functions or not. So yeah, give me a minute to reassemble it, and then we'll have a go at it. Alright, so the machine is reassembled, and my friend is here. He's going to keep a bag under the machine to catch any sort of dirt that's still in it. And I'm going to switch on the machine together with you, and we'll see if I repaired it or not. So here we go. Oh yeah, the machine works. Great, so another machine saved from the dump. So I hope you guys enjoyed the repair of a Sabo Mulcher. And well, see you for the next video.